The bottom and the inside walls of the cylindrical tank shown must be, in the figure, must be lined with sheet copper. How many square feet of sheet copper are needed? So I'm noticing it says the bottom and the inside walls. So the walls being, the lateral face, the lateral. It's not really a face, but yeah, the walls of this pyramid, and then the bottom. It doesn't say anything about the top. Also, I'm talking about lining something. We're talking about an area here. So it looks like it's going to be my lateral surface area. That's this stuff right here, plus one of the bases. This is not the total surface area of this particular cylinder, but we're not being asked to find the total surface area. We're asked to find what is the lateral surface area plus the surface of the bottom, because those are the only surfaces that we're coating with this sheet copper. It does say round to the nearest tenth. Okay, so let's figure out my lateral surface area is going to be 2 pi r times the height. So that's going to be, looks like we're actually given a radius here, the radius of 5 feet, so I'll just use that. 2 times pi times 5 times 12. 2 times pi times 5 times 12, which gives me 376.9911. So that's my lateral surface area. The area of my base, again, I'm only using one base here. I'm not using both of them because we're only lining the bottom of this cylinder, of this cylindrical tank with copper. This is just going to be pi r squared. So pi times 5 squared, that's 25 times pi, which gives me 78.5389, or 5398. And so in total, the total copper, how many square feet? Yeah, it looks like each of these are in square feet, because this was the radius and the height were both measured in feet, so I'm taking something without units, and the number of feet times the number of feet, so I end up with the number of square feet here. And this one I'm squaring the radius, which was in feet, so I end up with the square feet again. So in total, that means I can just add these together without having to do any unit conversions, since the units match up. I'll just take this number plus 376.9911. We'll get 455.53, 455.5309 ... This is round to the nearest tenth, which is going to be 455.5 square feet. A water district discovers a break in a 10-inch diameter pipe that has contaminated water over a 1.2 mile length. To treat the water flowing through the pipe, the water district needs to know the number of gallons of water flowing through this stretch of pipe. How many gallons is this? Okay, we're told how many cubic feet, 1 cubic foot of water, the conversion to gallons here. So we're going to need that, but I'm going to first need to figure out what the volume of water is in cubic feet in order to use that. I am noticing that they're giving this as a 10-inch diameter pipe. So this pipe is essentially, well, actually, let me draw this a little better. A pipe is essentially a very, very long cylinder. And if we're told the diameter here, well, most of the time when we're dealing with our formulas, I'm more interested in the radius. So if we're talking about a 10-inch diameter pipe, then this is a 5-inch radius. This distance right here is 1.2 miles. So I'm seeing all sorts of units. We're talking about cubic feet, we're talking about a number of inches, we're talking about a number of miles. It's going to be a good idea to begin with just to convert everything into whatever units I'm going to want to go towards. And I'm just going to go for cubic feet, because that way I can do my unit conversion at the very end more easily. So 5 inches is 5/12 of a foot. There's 12 inches in a foot, so 5 inches would be 5/12 there. And then converting miles to feet, there's 5,280 feet equals 1 mile. So if I do 1.2 times 5,280, this gives me 6,336 feet. That's the number of feet we have there. Okay, so my radius is in feet, my height, the length of this pipe is essentially going to be my height of this cylinder. It's a circular base, and the distance between these bases is exactly the length of this. So it's 6,336. So that means the volume in this pipe is going to be pi r squared, because that's we're doing area times height here. The area of the base is pi r squared, and the height of the cylinder is this 6,336. So pi times parentheses 5 over 12 squared times 6,336. This will give us a number in cubic feet. So 5/12 is in feet. Squaring it gives us square feet. Multiplying by this distance is feet. So that's where the cubic feet comes from. Alright, so we'll do pi times parentheses 5 over 12 squared times 6,336. That is 3455.75. 3455.75 cubic feet. Now we're wanting to convert this to gallons, and we know that 1 cubic foot of water, I'll notice I'm putting the cubic feet on the bottom here, 1 cubic foot is 7.48 gallons. So the cubic feet will cancel with the cubic feet. Looks like we need to just multiply this by 7.48, which gives us 25,849.02 whatever. Round this to the nearest gallon. Looks like I'll be rounding there. 25,849 gallons.